Yeah. Can you hear me?
You might talk louder.
Okay, I'll talk louder. Oh, wait. All right, perfect. I'll stop moving, and then I'll talk louder, so hopefully everybody can hear me. At the same time, I'll try not to scream. Oh.
Yeah, it's going.
All right, perfect. So thank you very much for still being here and I guess waiting for me to give my little presentation. All right, so I'm going to present, I'm going to tell you a little bit about 3D printing. And the title of my talk today is 3D printing, it's set to change our 3D perspective. So my presentation, my name is Mirabela Rusu, and I'll start by actually telling you who I am and what kind of expertise I have into the field of 3D printing, and specifically how I use this, as the previous title was saying, for work and for fun. So I will introduce what 3D printing is, and I assume most of you kind of have already an idea what 3D printing is, but I'll just outline the basis of it, and then I'll give a short history about 3D printing. I'll show you a couple of 3D printed objects, what material one can use in order to do the printing, what kind of medical applications are in our reach, let's say. And then I will talk a little bit about art and jewelry. I'll finish with a very short presentation about how to create or what one can use in order to create a 3D object that can be printed, where to print it, and all that stuff. So let's get going. So as I said, my name is Mirabela Rusu, and as you can actually see, I have a nice case logo because I'm an employee of Case Western Reserve University. I work there as a researcher. And so let me tell you a little bit about my 3D biography. So I'm not going to tell you much about my entire biography. I'm just going to tell you that since I was very young, I was interested, I loved mathematics and I loved geometry. And I had a hard time actually understanding or being able to go from that two-dimensional geometry in which kind of correlates very well with having a drawing on a sheet of paper, and then how you take that into three-dimensional geometry and get this into three-dimensional object. So as a child, I had a little bit of trouble, and in order for me to understand this transition between the 2D and 3D, I felt that I needed to recreate the three-dimensional world of what was on the paper. So that, me spending that much time in order to understand how what you see on the paper actually becomes a three-dimensional object allowed me to actually get a very interesting perspective in 3D. So my training, as it followed, actually was always kind of surrounding mathematics and geometry, specifically oriented towards 3D worlds and 3D objects. So I have an engineering degree in bioinformatics and modeling, and that's maybe not so interesting, but my PhD, so I have a PhD in University of Texas, where I actually work on structural bioinformatics. Structural biology in general, it's inherently a three-dimensional problem, deals with three-dimensional problems, because proteins and all the things that are within our body, they're obviously 3D. So then once I finished my PhD, I actually became a postdoctoral fellow, and I work in medical imaging right now at Case Western Reserve University. And I'll show you one of my research results and how it actually interferes or how it works in relation to the 3D printing. So as I mentioned, so I have let's say, expertise in solving biomedical problems, especially if they are in 3D. And I have a personal interest in scientific visualization. And you'll see some of my renderings, at least just a couple of the ones that I chose appropriate for this talk. And I also like to do 3D modeling. And you'll see a few of those. So 3D printing has become a thing for me in the last 2 years. So I have experience of a person that actually has been working with this for 2 years, but because of my prior expertise in 3D world modeling, I advanced quite a little bit in this world. So let's look now, I'll start talking about myself, and I'll actually tell you about 3D printing, which this talk is all about. So just the classic definition of what is 3D printing is the process of making a three-dimensional solid object from a digital model. And this diagram, and this is the wiki definition. I'm not inventing anything at this level. So the idea is that you will have a digital object, which is, can you see my mouse? No, you cannot. Can I have a pointer? Or, well, I'll point. Where you can see the purple shape that that one. Anyway, we'll get it. The purple shape that doesn't have any lines on it. That's the digital model. And then once you would like to actually 3D print something that looks that shape, you would try to. Thank you so much. You will essentially create it. Well, not really. Sometimes I shouldn't try to put it in my eye though, but no, I have a mouse, but it just doesn't show on your screen, on the other screen. That's okay. Anyway, so we have the 3D, the 2D in this model 2D shape, which is the digital model represented on the left side. And if we want to print it, we'll actually do layer by layer. We'll try to recreate this object. And we can see the different layers on the right side. So now if we want to take this from a 2D diagram and actually project this into 3D, we'll create, again, layer by layer, this three-dimensional object. And I'll actually show you a little movie on how this is done. This is just an example of how a 3D consumer 3D printer looks like. But what is more interesting is actually how this process is done. And this is a little bit of a faster kind of printing. It's fast forward. That probably takes a good 20 minutes to draw this. But I just kind of took this little representation from internet because I wanted to point how this is done. I do not own myself a 3D printer, so I could not show you this process beyond just picking something from the internet. So the idea is that you will create layer by layer using different kind of approaches. You will create that object. And just to kind of mention that 3D printing is actually not a new technology. 3D printing has been around for a while. It's a subdivision of additive manufacturing, which is around at least from the 70s. So this additive manufacturing, it's actually the technology for rapid prototyping in which you can create custom parts. It's just that 3D printing has taken off recently, I would say in the last 5 years, and it actually become closer to the consumer and a little bit further away from the industry. So I recently have been to one of these additive manufacturing conferences, and I think in a couple of months I will present some of my research results at this conference as well. So there are many things that are in the group of additive manufacturing, including 3D printing. So what we have just seen, it's called fuse deposition modeling, in which you have a plastic or a wire filament that is heated, and then a robot is controlling the movement of a robot that will actually allow the creation of that three-dimensional object. So 3D printing is considered as being one of these types of additive manufacture, as I said, and is considered to be one of the few that actually can, or if not the only one, that can create fully colored objects. One that is actually very interesting as well is called laser sintering. And this technology actually uses a high-power laser to fuse either plastic, metal, or ceramic material. And I have this. I will not show an example of it, but I find it very interesting because it's used for hip implants and skull implants and things like that. Anyway, so let's see what kind of materials one can print with. So here I'm showing just one little object that I recently created, which is made in plastic. Then I'm going to show you this, which is a fully colored 3D printed version of my face, which I'm holding here in my arm. Well, back then I had a little bit longer hair, which might be a little bit confusing, but it is me. Somebody has 3D scanned my face, just taken 4 pictures, and they were able to recreate the three-dimensional shape of, if somebody wants to pick it up and make it move around, I'm more than happy to show you that. And then they share that with me, and anyway, we can see the number of colors and actually the resolution of these models. Of course, this I printed more a little bit as a fun, and then to give it to my parents as a 3D version of a picture. I found it kind of interesting and fun. So another thing that I find very impressive, but I guess it kind of comes from this thing that 3D printing is used for rapid prototyping. It's actually the ability to print in steel. And this is a Klein bottle, I guess, or object, I don't know. But the object is actually printed in steel, and it really works as a bottle opener. It's a Klein key. And it's that geometric shape that actually has, it's normally unfeasible otherwise. So 3D printing, it's a good way of actually creating this as a 3D object. So one of the things that I started playing with, it's actually doing 3D printing in silver. This is just a skate wheel. I'm not going to tell you why I created a skate wheel, because I was just having a little bit of fun. It's an object that has about 5 millimeters in diameter, but I just wanted to see the ability of the technology to actually print in silver and check a little bit the different resolution of the scanners. And what I find also interesting is that one can actually print ceramic. So, of course, creating something that works for ceramic, it's a little bit more challenging because of weld thickness and things like that. But I'll tell you now. Let me if maybe you have any questions. Maybe otherwise I'll keep on going with. Okay, good. Then no questions. Then so yes, go ahead. Absolutely. If you wait another like 3 slides, I'll show it, and I actually have it here. So my research is in prostate cancer. So I work on prostate cancer, and specifically I work in characterizing the spatial distribution of cancer within the organ. So what you see here are results of my research. They're already published, so you can already see them. So what you see, the outline that is a little bit grayish, that's the shape of a prostate. And the colors actually represent where cancer is more likely to be found. Red represents high likelihood, and blue it's a little bit less, and green even less. And this is just a result that I created based on about 80 patients that have prostate cancer. Without going into the details how the actual results are obtained, what I wanted to do is actually do a 3D printing of those results. So one day I decided that it's time for me to try 3D printing, and I said, well, let's see how I can show this, because in the end I actually have an organ, and then I want to show something inside the organ. So what I choose to do is to actually cut half of the prostate away and just allow the view of the cancer, whereas the other half would be just the organ. So this gives an idea to physician actually how cancer is located within the prostate. Why this is interesting, or why this is important, is because when one wants to make sure that there is prostate cancer, a biopsy will be taken. So ideally you will want to go towards the regions that have a higher likelihood of actually having cancer. That will, what will be in an ideal world. Of course, this doesn't really work like that, so they actually just do random sampling. So they get poked in about 12 places. Anyway, so in an ideal world, you will want to try to go towards the regions that have a higher likelihood of cancer. So this little 3D object, it's mostly used as a training tool, nothing more than that. So I'll put it here. If somebody wants to pick it up, that's perfect with me. The other thing that I was interested, this is not really my research, but it's close enough from my research that I kind of thought it would be cool to play a little bit with it. So a friend of mine, which happens to be a neuroscientist, had a brain MRI. Now she's a healthy subject, so nothing wrong with her brain. But I wanted to essentially make a gift for her, and what I actually gave to her was her brain. So based on her brain MRI, I extracted the brain, and then I have it here. And what you can actually see, you can see nicely how the folds on the brain are. And as I was doing this model, I started realizing that her brain is not symmetric, which you kind of think when you look in a brain MRI, well, these sides are kind of looking the same. No, they're not. So anyway, I don't know if you want to look at it. But so essentially 3D printing allows you to get a little bit more a grasp of how things are really how things are really looking, because especially in medical imaging, we and in general doctors, they just look at this in 2D, and being able to actually create this and generate these three-dimensional objects is just somehow nice. So now, going back to your question, yes, I have created biomolecules. And as I said, given that I did my PhD in structural biology, and one of the research topics was structure of viruses, I wanted to create and 3D print a virus structure. So what we see here on this side is the West Nile virus. Again, why I wanted to print this one in particular, there is a story against probably each model that I have created. But I choose the immature form of this virus. That's the reason why you see these holes within. And I actually created a 3D version of this virus. And how it's used right now, it's as a pair of earrings. I absolutely love them. And all the people that have received them as a present, they love them too. So very often I actually use this 3D printing as gifts for the moment. And the other molecule that I wanted to represent or have in 3D printing, it's the mad cow disease molecule. And here I was playing with a couple of representations, so I'll tell you a little bit about structural biology. So here you actually see atoms. No, you cannot see my mouse, so okay. All right. So this is the actual structure of the protein. So the colorful spheres are actually the atoms inside. Gray, if I remember correctly, it's the carbon. Red is like the oxygen, and blue is the nitrogen. All right. So and the other surfaces, the blue and the purple, are actually what are called water-accessible surfaces, which are important when you design drugs, because molecules will tend to go in pockets within this protein. So, go ahead. Yes, it is. It's just 3 units out of it. So, yes, it's just 3 units of it. So, essentially, it will replicate to make a filament. So, it will be just 3 units of it. So, there will be a 4, 5, 6, 7, yeah. We'll make a big filament. This is how just one component within that filament looks like. Yes. Prions, it's a structure that actually increases. It's they are also known as being I would say viral proteins, if you want. Viral in the sense that they actually or infectious proteins. So what they do, they aggregate one to each other. So what you see here, let's say in blue, it's just 1 unit, and this unit will essentially replicate, not itself, but many of these units will kind of come together to create this filament, which will essentially grow so much that it will break the structure of the brain and where they actually are organized. All right, so these were just a couple of examples of 3D printed objects that I have created. But where I got my inspiration a little bit, if I can call it like that, for 3D printing is by looking at the presentation on application of 3D printing for prosthetic. So in this particular case, the person that we see here has lost his leg in a, I think, motorcycle accident. And there is this company that is trying to, I would say, create a 3D printed object that will kind of resemble the original leg, just to make it look more beautiful. And essentially, in this particular case, the person had a tattoo on that leg, so they wanted to recreate that. The fact that the person had a tattoo. And I find this like really amazing, a very nice application of something that in general is not specifically designed for this. And one of the things that I was amazed, at least I have seen this last week, a team in Netherlands has created they did a skull replacement. And they did this for a reason, because the person had a disorder that make the skull grow a lot, creating a lot of pressure on the brain, and it would eventually end up killing the person. So what this team from Wildrich in Netherlands, they decided to actually create a skull replacement made out of 3D printing. And initially, I just wanted to show the image of the doctor with the 3D printed skull, but I was like, this still does not show enough of how it is. So then we can actually see the patient and how the skull and how this fits within the thing. I think the surgery took about 30-something hours, and I'm still a little bit skeptical about having plastic in my head, but I guess if the alternative is dying, I guess I'm okay with having plastic for a skull. I assume they would have been able to print this in titanium. That's what they do for actually hip implants and skull pieces of skull. But I assume that would have been a little bit too heavy for these patients. So I'm sure there must be reasons why they choose certain things in certain ways. So I'll stop with the kind of a little bit the creepier things, and I'll show you a couple of applications that come from more like artistic and jewelry. This is not made by me. It's obviously, I wish I would have this much time and this much talent. So Joshua Harker, I really admire a lot his work. I don't know him personally, but I have seen this skull, and I think it is his own skull that it's used at the base. And he creates these very intricate objects, which one, they obviously are art, and there are many others. So if you have a chance, go to his website, and I assume if you like them, you can even buy these things, because they're for sure very, very interesting. The other thing that I find very, very interesting, it's the use of 3D printing for clothes and actual shoes. And I don't really know who she is, but she seems to be rather famous to a certain extent. But what is very interesting is the fact that she's wearing a 3D printed dress. We can kind of see through it, but I understand also why is that, because it makes it less heavy. And of course, printing that is cheaper, because when you print something, the cost comes from how much material you are using. So very often when you see a 3D printed object, the creators will try to minimize the amount of material that is inside. Thereby, they would create models that are they have holes inside. So one of the other things that I kind of set my mind of doing one day is to create my own shoes. So, but of course somebody has created this before, and this is just an example of a 3D printed shoe. I don't think I'll be able to wear that one. So going back again to the things that actually I am interested in modeling and 3D printing. So I wanted, last year, I decided that I want to create a replica of a Romanian, well, my accent tells you probably that I'm not from here. I'm originally from Romania, and I wanted to create a replica of this warrior helmet. It's made in gold, and it's dated in about 350 after Christ. So I just started modeling it. It was just my first object model, and it took quite a little bit of time, but I managed to get it finally. It's not perfect. I can't. It's very hard to create the level of details that helmet has, which makes me appreciate a lot the work of the people that really do that. But I try my best, and I have it here, and you can see how much details and how much resolution you can actually have with this. So you can go ahead and take it. So I'm not going to talk a whole lot more. This is just a little bit of a summary of the kind of knowledge, or I wouldn't say even knowledge, how one can create a 3D printable object. So nowadays, there are a lot of apps that will actually even do this on your cell phone or directly on the website of the services that do 3D printing. I personally like a lot 3D Blender, which is a software that is, not sure if it's open source, but for sure it's free. And works on all platforms. For sure, SolidWorks and Maya have been around for a while and have been used for the purpose of 3D printing. I totally recommend Blender, and there are a million of tutorials out there, including specifically for 3D printing and allowing you to check tolerances and wall thickness, because of course, what an object that is a digital object does not, can exist without any constraints, but the moment where you want to print it, there are obviously some constraints, one being the fact that the wall thickness cannot be too small, because then the material will actually break, will not print. It has to be geometrically correct. There are a whole lot of constraints that one has to follow. For example, the helmet replica that I initially created had about 500,000 vertices. I don't know if, so going a little bit on what a vertex is in this case, well, it's each one of the point within within that object. Well, for something that had 500,000 vertices, it took a while to upload, and also it seemed that it was not exactly printable. So once I finished the replica, then I realized it's not printable and then I start all over again. And this time I did it a little bit better, a little bit cleaner. So it took a couple of iterations until I was able to create something that was actually even printable. So my experience with 3D printing is that at least I personally do not own, as I mentioned, I don't own my own printer. I use two services. I use Shapeways, which you can see that nice box there, which is a company based in New York. And I also sometimes use iMaterialize, which is a company based in Belgium. I like them because they have all the materials that I talked about. And however, but the problem is, of course, it takes a little bit of time to get the objects when you send them. You might also have issues. The last thing that I printed came out broken because the wall thickness was not exactly ideal. I pushed a little bit the technology. The outcome was I failed. So, but that's that tells me a little bit how to make my models better. But I could, or you could as well, buy your own printer. And actually, Staples has one for $1,500, and then Microsoft has a second one, which is about $2,000. However, they only can print plastic, and it's that wired kind of approach of 3D printing. So if you want the colorful materials and all that, you still not, those are not yet in the price range that would be easily used by a normal consumer, like, let's say, myself. I think one of them will be easily in the 50,000, if not more, for these printers. So with that, I will actually conclude saying that 3D printing is commonly used for rapid prototyping and custom design of objects. The application, as we have seen, are very diverse. There are a large number of software and apps that can actually allow you to create your own three-dimensional objects. And in the end, there are some limits, but not many to this technology. So the limits it's essentially where your imagination stops. So with that, I will stop, and I will wait for questions while I will show you a little movie that I think it's probably one of the coolest things. So this is a 3D printed spider. Oh, on my screen there is a 3D printed spider. Yeah, it's coming. All right. Okay. Maybe. And this 3D printed spider, it's actually dancing. So while we look at this little 3D printed spider dancing, you can ask questions. I can even make it. No, okay. So somebody is actually selling this for a lot of money. Go ahead.
How has?
I guess the music will have to stop because I cannot hear you. Go ahead.
How much has 3D printing helped your research work compared to computer use for your research work?
So can you repeat your question? How much is 3D printing?
How much use have you gotten out of 3D printing for your
how much
research
use
work?
I got? I think for the moment to work, it's still pretty reduced. It's more a hobby than really something that is super useful. Doctors like to look at them. They're usually a fancy thing that I get to show to people coming around my office. But besides that, I think it's mostly a teaching tool. But as you could see, the thing is that in surgery, I think this kind of 3D printing has a lot of use. As we can see, the thing with the skull, which when the skull is liberated, okay, that's very, very interesting. And there are a couple of other medical applications that are really, really surprising. One of them, they recently did a stunt, I think. So there was a kid that had some sort of problem with one of his airways, and they created a little structure around the airways made out of 3D printing, which they implanted within the baby so the airway could grow normally. So I think there are quite a number of applications that are really specific and very useful besides the kind of having a cute object laying around. So I think that's for sure. There is one aspect, and there is the other aspect. Very often when doctors have complicated surgeries, for example, I know of a case in which there were these twins that were essentially joined at the skull level. So they wanted to separate them. So in order for doctors to do such complicated procedures, they actually had the skull of the twins 3D printed, and they practice on how to separate them using essentially that kind of a model. So from a training perspective, and it's also used in the same context also to create the tool, or figure out the tools that they would even need in order to do such a procedure. That is not common. So I think that there are quite a number of applications at that level, and I know of I know of a couple of other medical applications that are really close to. Yes, you might have one day some part that could be 3D printed. As I said, like hip implants, skull implants, and things like that.
Two questions for you. Did you use a 3D scanner to scan the mask when you did that? And then the other one is about how much would a sandstone model like that cost to get printed through those services?
Which one are you talking about?
The Romanian mask.
Oh, no, actually that lies very nicely in a museum somewhere far away, I mean, in Romania. So no, I have only had essentially that picture and a couple of more pictures that I could find online. So based on that, I also kind of extrapolated on what I could see and what I thought, because as you could see from my presentation, the mask is missing a part. Can you see? Oh, you can actually see my mouse in this one. The mask, the helmet is actually missing a part here. So I created that part because I thought it would be very weird if I don't. So okay, so now going back, so this, so no 3D scanner in this case. I would love to have this. I was thinking that I would go into that museum and try to do that. I'm not sure if they would allow me to, but on the other hand, what is sure is that the one that you are holding, the little one that I pass around, I think that's about $20. In printing, I mean, all the objects that I'm holding, except the yellow one, which is kind of big, the prostate, all of them are less than $20. So that one, it's about 50, but it's 50 because it's full. It's very heavy. So if I would made it hollow, it will be probably less than $20. But all the other ones are actually within less than $20 to print. Yes.
I was wondering, how did you get the data from the MRI and change that to something that you could print?
Well, I'm the expert in this field, so yeah, I create essentially I go and segment the brain out of the MRI. So there are software that are used for this purpose. They could be semi-automatic, they could be actually manual. So I just stay there, contour each slice, which is actually what I did for this case. It takes a little bit of time, yeah. Depends. This particular scan was done, it's a research scan, which means it's a lot more, the resolution, it's a lot better than actually what you'll get in a clinical setting because, well, being a research scan, they want to extract as much information as possible for whatever disease they are studying and kind of see a little bit the limitation of the imaging in itself. So, yeah, it was a little bit of work back then. But now I know that there are automatic ways of doing that. Go ahead. Or don't go ahead.
Do you know what the lifespan, let's say, for PLA plastic would be in terms of like?
It's plastic, so
like
if you ask me, it's
a biodegradable?
No,
type
I
of?
mean not the ones that you would hold here. The ones that you have here, they're just regular plastic. I don't think it would be any more complicated than a one that is used for printing a water bottle or whatever, having a molded object. However, the ones that I was talking, what I said for that little baby, that they were using 3D printing in order to actually hold the airway in place, I think I specifically look at that, and that material was biodegradable. Cool. Because that's where the actual challenge becomes. Is not anymore about, you can print plastic, you just melt it and you just put it in that, and it works. I guess it has to have some sort of characteristics, but it's not a big deal. But of course, if you have something in your body, we kind of would like to either have it biodegradable or at least something, I know, so that particular material was biodegradable. And so the body would essentially be able to, over time, actually dissolve that and get rid of it. Of course, it's all beginnings. That's not, so it's, I assume they would need to do a lot more research in order to make sure that, all is good after in 20 years or things like that with that material. But I think that's the case. I know for sure with the ones that, I should have actually put a picture of that. With the hip implants and with the knee implants and all that, the structure, the laser creates this very interesting mesh on the surface of the titanium, because the idea is to have the bone cells actually occupy this cell, this mesh that comes on the tip of the object, because you want the actual bone to grow back and to cover all this, because of course our own bone is a lot better than titanium for the purpose of walking. Yes.
Were they doing that? They were printing like cartilage or something like that and forming a shape out of cartilage, and then they put it in a petri dish and let the cells occupy it?
I think that's a very old application. I have not seen that for a while. I know that they can print cell life. This conference that I've been last year, it's called Rapid, was in Pittsburgh last year. This year, if you're interested, you can just join them. They are in Detroit. They were showing actually a system in which they were printing whatever cells you wanted to print. The problem is not so much the printing of the cells. I think that's not really a problem. What is a problem is, and that kind of goes a little bit into the technical details of how to do this, is how to create a structure that is actually, the cells need food. So besides putting the cells, you actually need blood vessels, and you need veins, and you need all this kind of infrastructure around there. And we are nowhere close to, actually even understanding probably how all these things work, and then even be able to actually recreate this in 3D printing. So I think the idea of printing a couple of layers of cells, I think that is for sure not a problem whatsoever. And I know about a couple of applications with skin grafts and things like that, and I think that's probably one of the examples. Yeah.
All right, this is a little off topic, but since nobody else has any questions, these prions.
Okay, let me just clarify one thing. I am no specialist in prions, so I'll tell you as much as I understand of how they work. Go ahead.
Oh, well, I thought maybe.
And we'll Google together if you want.
Okay. I heard that prions, the mad cow problem was in England, so they burned up all the mad cows.
Uh-huh.
Now, I heard that they've sold the ashes to fertilizer companies, which they then spread on the grass, which the cows are currently eating this now. Would that be a problem? Could this thing survive the fire?
I think that's something that I would not be comfortable answering. I don't know. I don't think so. I know there, and I don't think that's. Would be a little bit skeptical. So okay, I'll tell you my personal opinion about it. I'll be a little bit skeptical given that there was so much craziness around the mad cow disease. I'll be skeptical that they burn them and they actually give the ashes to as the fertilizers. I would find that very unusual. And I would not think that they just throw it. And plus, actually, ash, as much as that I know, has no nutritional value whatsoever. So I would be I don't think it would make a good fertilizer. I don't know. Well, but it's like, exactly. It's like I read this on the internet. Must be true. It goes in the same direction. I would be very skeptical to believe that they really do that. But now the question is, would that even pass? There are a lot of debates now in science, even going beyond would the human really get mad cow disease if you really eat the meat that has mad cow disease. I'm not even talking about. So there are even, as much as I remember, the knowledge was that even that would not really be a problem because having this disease go from cross species would not really be such an easy thing. However, well, there are humans that still eat. There are still cannibals out there, and they still, especially, and they like to eat the brain because that seems to be a kind of an important organ. And I look more into that direction than thinking about using the ash as a fertilizer. So if nobody has any other questions, I'll let you go for dinner. Thank you for listening to me.